All right, guys. Cool. So we'll do the register, and then we're going to get right into it today because we've got quite a lot to try and get through. So if you guys could all type your name. Why am I so bright today? Well, whatever. Cool. Yeah, if you could all type your names, that'd be great. And we're going to be looking at geometric sequences. I'm just going to open the blinds and see if I can get a bit more light there. It's a bit better in there. Cool. Right, so where's my register numbers? So we've got Jake, and Jay, Harry, Danny, Chloe, Guy, Scott, Nuala, Elliot, Becky, Billy, Callum, Louis, Tristan, Ollie, Lucy. Oh, Lucy made it, cool. George. All right. Yeah, everybody, bro, awesome. Okay then. So yeah, we're going to be moving on with geometric sequences and series, which is the next kind of topic in the sequences and series bit. Just so I can again remind some of you, I'm still missing a few bits and pieces. See if I can just open this. Yeah. So I'm still missing the stats mechanics from Becky, Tristan, Callum, and Ollie. If you guys can get those to me as soon as possible, they have been marked down as late. I need them by the end of the weekend, otherwise emailing tutors. And I'm still missing skills checks from Becky, Tristan, Nuala, a couple from you, Scott, all of yours, Billy, all of yours, Callum, all of yours, Jake, Danny, and Ollie. So if you get a lot of similar names there, make sure you're getting all the work done, guys. If you're not getting half the work done, the assignments and skills checks are as important as all the other stuff. You're missing half of your maths education, and we're not doing this stuff again in September. We're going to go right into the second year, so you need to know this stuff. Make sure you get it all done properly. Anyway, so we're moving on to geometric sequences series. So we did arithmetic last week. So remember, arithmetic is when a sequence increases or decreases by a common difference. And when we did that, we had un as the first term plus n minus 1 times the difference. We had Sn, n over 2, 2a, plus n minus 1, d. So those are our equations where something goes up by d each time. A geometric sequence is it increases or decreases by a common ratio. In other words, each time we are timesing our first value by ratio, we use the letter R for ratio just like we use D for difference. Questions are going to be similar, but we need to kind of work out a new nth term equation and a new sum of n term equation. So we'll try and derive this ourselves. So if we say our first term again is going to be a, our second term, if it's going up, if it's increasing or decreasing by a common ratio, our second term will be a times by r. Our third term would be a times by r again, so ar squared. Our fourth term, same again, times it by r again, so we're going to get a times r squared times r is going to be r cubed. And looking at this, you guys should be able to come up with a pattern for what is our nth term. So could you all have a quick think? I'm going to start a not Google question. I'm going to start a Microsoft Teams chat. Can you all have a think and see if you can come up with what is the nth term? So your new n equals, and it's going to be kind of fitting the same pattern we've seen with all the previous terms. So I'll start that chat now. And you guys can comment the answer, or you can try and write the answer if you think it's hard to type. Cool. So I'm inviting you guys to Teams now. Cool. Right, anybody got any ideas? What is the nth term going to be for our geometric series? Any ideas? So first term was a, second term was ar, third term was ar squared, fourth term was ar cubed. What's the nth term going to be? So it looks like it's going to have an a in it, because everything else has an a in it. It looks like it's going to have an r in it, because everything else has an r in it. What's the power going to be, though? So if we look, our first term had no r's, our second term had one r. Danny, yep, brilliant. Our nth term is going to be ar to the power n. Take 1. So we can say 4 and 3 go 3 and 2, 2 and 1, n and n minus 1. So that is our nth term formula, which you need to learn for a geometric series. So an example of a geometric series could be something like 2, 6, 18, etc. So if we looked at that, that has a ratio of 3, because we're timesing by 3 each time, and a first term of 2. We could then use that to work out any term in that sequence. Yeah, Lucy, you got that as well. Good. Anybody else answered? Cool. All right, so that's our nth term equation. I'm going to leave that. We'll come back to that later. I want to get all the deriving done so we're in the same place we were for arithmetic series, and we can just start applying both. So we now need to prove the sum equation, and it's similar to what we're doing the whole Gauss thing on Wednesday. Again, it's a proof that you guys might need to do. So the way we do this one, we write out Sn. It's going to be the first term plus the next term plus the next term. Skip all the way to the last term. So there's our sum of the terms in a geometric series. And the method we try and do to prove the sum equation in this one is we times that by r. So we write out Rsn. So I'll put the steps down at the bottom. Oops. So we write out Sn. We then write out Rsn. So I'm going to times all my expansion at the top by r. So we're going to get ar squared, ar cubed, ar to the power n. And then we're going to subtract these. So let's add that to our text box here. So we're going to get Sn, the top one, take the bottom one, Sn minus Rsn. And what's going to happen when we subtract these, A is going to take away 0, because A is going to take away nothing because there is no A to take away. The AR at the top is going to take away the AR at the bottom, so I can think about cancelling those two out. The AR squared on top is going to take out the AR squared on bottom. The AR cubed on top, even though I haven't drawn it, is going to take out the AR cubed on the bottom. The ARM minus 1 on top is going to take out the ARM minus 1 on the bottom, and we're just going to be left with these two. So we're going to be left with A, take AR to the power n. So that's what we've got to. Right, we're going to factorize each side, so we're going to add that to my list of steps here. Factorize both sides. So if you factorize the left-hand side, we're going to get Sn 1 minus r equals a 1 minus r to the n. And then we're going to divide to find our equation, which is going to be Sn equals a 1 minus r to the n divided by 1 minus r. And that is our sum of n terms in a geometric series, and that's the proof you need to know for deriving it too. Right, I'm going to give you guys a minute to copy that down, read through it, read through the steps, and ask me if you've got any problems with that. I'll make it 2 minutes, because that might take a little while. So 2 minutes just to go over that, think of any questions you might have, any bits you might not understand in the algebra, because you need to be able to replicate this proof. So 2 minutes starts now, copy it down, have a think. I clicked the wrong timer. Do you guys want 2 more minutes? Sorry, I was wondering what you're getting on about there, Jay. I'll give you 2 more minutes, and I won't click the wrong page this time. So just have a think if there's any questions you got on that one. Okay, so Jay said about the factorizing. What we're trying to do is get from this equation to Sn equals. So to get Sn equals, I need to factorize out Sn, so I just got one of them. So that's what's happened here, I've taken out a factor there. This bit, we could leave it like this, but it's kind of confusing to have a in two places. So we factorize both sides to make it a bit simpler. And then we're just dividing down. We need to do that in order to get S on its own. At the moment we've got two of them, we can't just say Sn equals when we've got two. So whenever you've got two of the value you want to solve for, you can factorize it out to get Sn on its own. Does that make a bit more sense? Has anyone else got any questions? Are you guys all alright with that? It is just an equation that we can use, but occasionally they ask you to prove it like they ask you to prove the arithmetic series proof as well. Right, so we're going to try and use these two equations. That's all the real new stuff for today. The rest of this is going to be using both of these equations. So we're going to start off easy, trying to decide which of these are geometric sequences. For the ones that are, give the value of the ratio. So having a look at these, which ones count as, I might do all of them actually, I did scribble out half, but I don't think it'll take you too long anyway. So have a look through these. Can you guys identify which are geometric? And for the ones that are geometric, find the common ratio. If they're arithmetic, say they're arithmetic. So we're basically looking at these and trying to decide what kind of series they are, whether they're arithmetic or geometric. So I'm going to give you guys 5 minutes to look through these. It shouldn't take you, I don't think it'll take you longer than that. But if you could comment your answers either in the YouTube chat or in the Microsoft Teams chat, that'd be excellent. So 5 minutes starting from Cool. Right, a couple of you answered. Let's see what you thought. A few actually. Let's see what you said. Cool. Right. First one. So first one, 1 times 2 is 2, 2 times 2 is 4. Yep, so this one is geometric. Yes. That's a bit big. And r equals 2 there. We're timesing each term by 2. Good. B is not geometric. This is actually an arithmetic. So this is no. Arithmetic. C is taking away 4 each time, so that's a no. Again, that's arithmetic. Cool. D is what we're doing here. Looks like we're timesing it by 3. Yes. R equals 3. Next one, we are halving it, so this is another yes. R is a half, or 0.5 in that one. Well done, everyone spotted that. 5, F is yes again. It doesn't look like it, but we are timesing it by -1, so it's going -5, -5, 5, -5 each time, so R is -1. G, yeah, you could say this is, I suppose. It's a bit silly, but yes. R is 1. And for H, again, yes. We're timesing it by R is -1/4. So whenever you get a question on sequences and series, this is your first step. Ask yourself, is it arithmetic? Is it geometric? And if it's neither, you still have to do the question, but you won't be able to use any of the equations we've done. So the equations we did on Wednesday are only for arithmetic. The things we're looking at today, only for geometric. So always do that check. Sometimes it won't be either, and if it's not either, it's going to be something easy that you can do with logic. But if it is arithmetic or geometric, you can use the equation. So that's your first step, is checking. Okay, just to make it a little bit easier, we're going to take one of these. So let's have a look at, we'll go for question A. I'll crop this actually. Clear. Oh no. Clear drawings in. Okay. Just so we get, because the next questions are getting pretty tricky, we're going to just take this series here. There it is, Q. And I would like you guys to find the 11th term. And then part B, find the sum of the first 8 terms. So using the two equations, you should have them written down. Let me know if you need them, and I can write them back up. You should have them written down anyway. Could you guys find the 11th term and then find the sum of the first 8 terms? So I'll give you 4 minutes for that because it shouldn't take you too long. So time starts now. Right, I can't see any answers, guys. So for all these, can you try and send me answers as you get them? We'll work through this one now, though. So find the 11th term. So my equation is un equals a 1 minus r to the n over 1 minus r. No, it's not. That's the sum. What am I talking about? Sorry. Un equals a r to the n minus 1. There we go. So the 11th term, u11, is going to be 1, which is our first term. The ratio is 2 times 11 take 1, which is going to be 10. So we need 2 to the power 10 times by 1. Where's all my counts? Here we go, some answers popped up. So 2 to the power 10, 1024. Good. Awesome. Right, find the sum of the first 8 terms. So now we're trying to use that sum equation I wrote earlier. So we want S of the first 8 terms, which is going to be A 1 minus r to the n over 1 minus r. So that's going to be A was 1. 1 minus, all of you are commenting now, 2 to the power 8 over 1 minus 2. So we can type all that straight into the calculator. And we get 255. Awesome. Yeah, well done, everybody. Yeah, great. Well done. Cool. Okay, so really it's no harder than the arithmetic series is so far. It does get slightly harder, but we'll get there. Okay, so a little bit more difficult now. If we don't see the ratio, how could we find the common ratio? So in that last one, if we just go back, if I was finding it hard to decide what the common ratio is, I could just take a few terms and divide them. So, for example, 4 over 2 is the same as 2, and that's the same as 16 over 8 equals 2. So to find the common ratio, divide a term by the term before it. Yep, so if you take a term, like 32, divide that by 16, and you've found what you times it by. So we're going to be using that now. So this is a 6-mark question. I'll give you guys 6 minutes. So you've got 3 terms there. They're all unknown though, you've got x's in them. We want to show that that's true. We want to find the value of 20th term and then state whether 4096 is a term in the sequence. So have a think about this. It's a little bit trickier. Yeah, 6 minutes to see what you guys can do. And please comment your answers in the chat or in Teams. Alright, let's see what you got, guys. If you could post your solutions. So we've given three terms. We're told it's geometric, so we know that 2x divided by 8 minus x should equal r. We also know x squared over 2x equals r. So I can set both those things equal to each other. So we can say 2x over 8 take x equals x squared over 2x. And now we can try and solve this. So if I cross multiply both sides, I think is probably the easiest route for this. So I'm going to say 2x squared equals x squared times 8 take x. So we're going to get 4x squared equals 8x squared minus x cubed. Get it all on one side, so I'm going to add it or take it all onto the left to get x cubed minus 4x squared equals 0. So that's the first bit. Find the value of the 20th term. So if I solve this to find x, we can then find out what r is and then go from there and working out the whole series. So if I try and solve this then, so we're going to get x squared as a common factor, x take 4. So either x equals 0, which isn't going to be much use in the series, or x equals 4. So we'll say x equals 4. Then I can find my first term is 8 take away 4, so my first term is 4. And my common difference, well, we know is x squared over 2x, so in other words that's going to be 16 over 8, so the common difference is 2. So the common ratio is 2, so r equals 2. So using those two bits, I can do the rest of this question pretty easily. So I find the value of the 20th term, that's going to be u20 equals a r to the n minus 1. So that's 4 lots of 2. 20th term is to the power 19. So calculator out. 4 lots of 2 to the power 19, which, oh my god, that's huge. Is that real? Yeah. 2097152. So 2,097,158. Cool. State with reason whether 4096 is in the sequence. So we're going to set that equal to the term. We're going to say 4096 equals 4 lots of 2 to the n minus 1. And we're going to try and solve this and see, is there a value of n that will give us 4096. So I'm going to divide both sides by 4. Which gives me 1024. Is 2 to the power something 1024? Well, if I want to try and solve this for n, I could log both sides. So I'm going to log 1024 equals log 2 to the n take 1. I can then use the power rule on this, so I can take n minus 1 down the front. So we get log 1024 equals n minus 1 log 2. I'll divide 1024 by log 2. So log 1024 divided by log 2 equals n minus 1. Let's see if that gives me an integer. Remember, log means log base 10, so you can always type the 10s in. If you work that out, we get 10. So we get 10 is n minus 1, so n equals 11. So I don't know if we needed to do all that, but yeah, we've proved that. N equals 11, so yes, it's in the sequence. It's only worth 1 mark, so maybe that was a bit overcomplicated for what we were meant to do there. What was our first term again? First term was 4. Equals 2. Yeah, I mean 4096 divides by 4 and it divides by 2. So because it divides by 4 and 2, yeah, we can argue it is a term in the sequence. So maybe that's a quicker way of doing it. But this log thing is useful for what we're going to be doing later on today. Right, on to the next one. Could you guys try this one? A little bit trickier, 4 marks, got to use logs. see how you get on. I'm just going to have a look through your answers to that last one quickly. So Elliot was first. Wait, no, it wasn't. That was from before. Has anyone done this one? George. George, you made it a lot harder by not solving the quadratic. Yeah, have another look through and check you're right there. Has anyone got any questions? Was everybody all right with that last question? We'll see. We'll try this and see how we get on. I will wait until there's some answers given though. So I'll give you 5 minutes for this, starting now. Cool, right, Harry's done. This one looks pretty good. So geometric sequence has first, so we need to write all this information in terms of our equation. So we know the first term, A, is 200, and R is P. Okay. We know the sixth term is 40, so 40 is 200 times P to the power 6 minus 1, which is 5. Show P satisfies this equation. So we need to basically rearrange and solve this thing. So if I divide both sides by 200, we're going to get 4 over 20 is P to the power 5. I can then kind of sort this out and get 1/5 is P to the power 5. I can then log both sides to get log 1/5 is log P to the 5. Use the power rule again to bring the 5 down the front. Log of 1/5 is 5 log of P. Cool. I'm going to take that from both sides to get 5 log P minus log of 1/5 is 0, which is close to what they've got. And then the last bit is realizing we can use the power rule again to bring up that minus sign as a negative power. So I can bring that up to there, to the minus 1. And 1/5 to the power minus 1 is 5. So we get 5 log P plus log 5 equals 0. Cool, and now it wants me to solve to find P. So, 3 sig figs. Okay, so we're going to, there's a few ways you could do this really. I'm going to subtract log 5 from both sides and divide by 5. So we get log P is minus log 5 over 5. And then I'm going to e both sides to get P is e to the minus log 5 over 5. Sorry, no, not. That would be lent. I'm going to do 10 to the power minus log 5 over 5. So 10 to the power, and as I said, there's a few ways you could do this. Minus log 5 over 5. You should get P is 0. What do you want to do? 3 sig figs. 0.725. There we go. Let's see if you guys have got that. So Harry, yeah, you agree, you did it slightly differently, that's fine. Lucy, first bit's fine, haven't done the second bit though. Right, we're going to keep going, guys, so if you are finding any of these difficult, please go back and rewatch the video and then email me if you've got any parts that you're still stuck on. Next one, 4-mark question here, so see if you guys can give this a go. So 4 minutes on the clock, or maybe 5, these are taking a little bit longer. So write out everything you know in terms of the equations and then try and solve to find out. Right, just wait and see if there's any answers for these ones. Can't see them yet though, but let's get started. So first term's A, so we need to find A and R this time, so it's a little bit trickier. So the sum of the first two terms is 4.48. So we can say S2, or 4.48, is A 1 minus R. It's the first two terms, so we're going to put 2 there over 1 minus R. The sum of the first four terms is 5.1968. So that's going to be A 1 minus R to the 4 over 1 minus R. So we need to solve these two equations simultaneously. Cool. Right, so I'm going to times up by 1 minus R in each case. I'm going to get rid of the text now because we need the space. I'm going to write the other one on top. So 5.1968 equals A 1 minus R to the 4 minus R. I'll just write this one again a bit smaller. So two equations, two unknowns, you want to try and solve these. And there's a few ways to do it. We could solve for R, we could solve for A. I think probably easier to solve for A in each case. Yeah, let's first start by rearranging. So I'm going to times up the 1 minus R in both cases to the top. So we're going to get 5.1968 times 1 minus R equals A 1 minus R to the 4. And the blue one will be 4.48 1 minus R equals A 1 minus R squared. So if I divide both the other bits down, we're going to get A equals in both cases. I can set those A's equal to try and find out what R is. I've actually forgotten what the question is. Are we trying to find A or trying to find R? We are trying to find cool, okay. So yeah, as I said, divide the other two bits down. So the red equation becomes 5.1968 minus R over 1 minus R to the 4 equals A. And the blue one, 4.48 1 minus R over 1 minus R squared equals A. So I can set those two bits equal to each other. So let's do that. So 5.1968 1 take R over 1 minus R to the 4 equals 4.48 1 minus R over 1 minus R squared. Alright, so in both cases I can get rid of the whole 1 minus R solution, so I can get rid of those bits, basically divide each side by that. I'm then going to cross multiply the 1 minus R and 1 minus R to the 4 to get 5.1968 minus R squared equals 4.48 minus R to the 4. Right, so if I expand all this, we're going to get a quartic. Yeah, I think this will work. We'll do it this way. So we're trying to find R. We've got two equations with R in. So if I expand both sides, we're going to get 5.1968 minus 5.1968 R squared equals 4.48 minus 4.48 R to the 4. Get it all on one side so it looks like a quadratic. 4.48 R to the 4 minus 5.1968 R squared. Take 4.48 from each side, so that's 5.1968. Take away 4.48, which gives me 0. Plus 0.7164 equals 0. So it doesn't look much like a quadratic, but I could substitute. I could say R squared equals Y, and then we get 4.48 Y squared minus 5.1968 Y plus 0.7164 equals 0. So I can solve that using the calculator. So 4.48 minus 5.1968 and 0.7164. And we get two values, we get x. Oh, these are both pretty horrible values. Right? We get, so y equals, or yeah, y equals 1.001 or y equals 98. Okay, well those aren't really y, those are really y squared. So if I put y squared back in, or r squared back in, we got r squared equals these things. I think something's gone wrong here, because I'm going to get 4 values and it said 2. Give me a sec, guys, I will try and see what I've done. Yeah, I'm going to go back a few steps. Yeah, back to up here before anything went kind of wrong. So at this point, I'm going to do some difference of 2 squares. So if you notice on the bottom there, 1 minus r to the 4, that's a difference of 2 squares. So I can say 5.1968 over 1 plus r squared, 1 minus r squared. It's 4.48 over 1 minus r squared. So I can actually cancel out the 1 minus r squared on each side, and then we're left with a quadratic, which I think is going to work a bit better. Okay, so if I times up by 1 plus r squared, we can now work on solving this. So 5.1968 is 4.48, 1 plus r squared. Divide both sides by 4.48, so 5.1968 divided by 4.48 is 1 plus r squared. So if I work that out on the calculator, 5.1968 divided by 4.48 gives me 1.16 is 1 plus r squared. Take away 1, so we get r squared is 0.16. Square root that, and we get r is plus or minus 0.4, which I think we would have got the other way around, but we also would have got a solution of r is plus or minus 1, which doesn't actually make any sense, and I think that's because of the way I went about solving the quartic. Does r have to be bigger than 0? Because it would then kill off 2 of the values. No, that's not the problem. R can be negative because you can oscillate between positive and negative values. So that's not the problem. I think the problem here was that I found r is plus or minus 1, which doesn't actually give us the sequence that they gave us in the question. Yeah, so that's why. Weird question though. It shouldn't result in 4 values, but yeah, there you go. So 0.4, and that we would have found that from the other solution as well, but I wanted to double check why the one was disappearing. That was a bit confusing, guys, so don't worry too much about that. Right, we've got 20 minutes left. Let's try this one, and then we're going to move on to a couple modelling questions. So 4, 5, 6, 7, 8, 9. I'll give you guys 10 minutes for this one. So give this a go. Cool, all right, quite a few responses to that one. I'll go through it and then I'll have a look at what you guys have said. So if you're still doing it, try and see if you can get your answers in before I finish. All right, so we've got the first three terms here. So this is very similar to that last question, or the question we did just now. So we're going to do k over k take 6 is the ratio, which should be the same as 2k plus 5 divided by k. So we're going to get k squared on one side and k minus 6, 2k plus 5 on that side. Expand both sides. K squared equals 2k squared minus 12k plus 5k minus 30. So simplify all this. We're going to take k squared from each side to get k squared minus 7k minus 30 is 0. So for 4 marks, I think that's pretty fair, to be honest, as long as you can spot what it's actually asking you to do. So we've done that, hence find the value of k, so we're factorising this quadratic. We've got 30, so I think it's going to be 10 and 3 for factorising, so k minus 10, k plus 3, so k, they tell us k is positive, therefore k is 10. Hence, find the common ratio of the series. Well, the common ratio we know is 1 divided by the other, so we're going to do 10 divided by 10 take 6, which is 10 over 4, which is 5 over 2, so k is 2.5. If we wanted to, we could check that with the other one, so we could try putting k into there, so we get 20 plus 5, which is 25, divided by 10, which is also 2.5. So check it, and we know that we've got it right. And lastly, find the sum of the first 10 terms. So we're looking for S10. So that's going to be the first term, which is going to be k take 6. So that's 2.5 take 6, which is going to be, what, minus 3.5? 1 minus r. The ratio was... Wait, no, k is not 2.5. K was 10. I'm talking rubbish. Sorry, 10 minus 2.5 to the power n, 10 terms, so n is 10, divided by 1 minus 2.5. Sorry, got my k and my r mixed up there. So, work that out, get your calculator, 10 fraction 1 minus 2.5 to the power 10 over 1 minus 2.5. Work it out, and we get 6, 3, is that right? Six, 3, 5, 7, 1. Point nearest whole number, so round up to 6, 3, 5, 7, 2. Right, Guy, I think your part D is wrong. Let's have a look through teams and see what you guys will put. Oh, why does something wrong here? 10k is 10. Oh, the first term's 4. Sorry, sorry, ignore me, Guy. That is wrong. Of course, sorry. Alright, let's do that again quickly. 1 minus 2.5 to the power 10 over 1 minus 2.5 gives me missing a bracket there. There we go. Yeah, cool. So you guys are right. Sorry about that. 2, 5, 4, 2, 9 should be your answer. So yeah, Lucy, nice. Guy, nice. George, yours is rounded differently there. I don't know why. You've rounded it to the nearest 100, not the nearest whole number. So check that over. Chloe, yeah, so far so good. Elliot, yeah, brilliant. Cool, all right, nice one, guys. All right, we've got 5 minutes left. I will leave you with this to have a think about, and we'll start with this one on Monday. Next week, we're still doing sequences and series. There's still quite a bit left to do. We've got one more week on that. And then we've got 2 more quick topics before the end of term. Make sure you do the skills check and the assignment. I'll be looking at that tomorrow. So if you haven't done it yet, do the skills check, do the assignment, upload them tonight. That should be 31 now. Wait, I think that's 31. Let me check where we got to. So I have marked up to when it opens. There we go. I have marked up to 30. Yeah, so it should be 31 done today. A few of you haven't done 30, or a few of you are missing quite a lot of stuff. Get that caught up on this weekend, please, guys. All right, cheers, and I will see you on Monday. If you want to start this now, we'll be doing that at the beginning of the next lecture. Have a nice weekend. Cheers.